Methodist English. And hi everyone. Welcome to this afternoon here at Jornada JEAmbi. Thank you so much for this collaboration with us. My name is Diana. I'm the co-president of the University of Lisbon Alt Protein Project that, if you don't know about, we will talk about a bit just before the roundtable. So, to start, this is a brief part of my background. But you see there the University of Lisbon Alt Protein Project is more or less one of our recent projects that started in the University of Lisbon. But I really like to show this slide when we are actually talking here at IST, because I came to IST to do my master's in 2019, and basically what you see there from 2019 on is just projects on alternative proteins. And here at IST, I'm very proud of saying this because actually we are like the #1 research institute on cultivated fish, and you can see there so a lot of projects. But today, to focus on the University of Lisbon Alt Protein Project, this was actually a moment when I was developing here research with my colleague Elder, that we actually discovered by actually just being around at IST, that the research was in a way that is not actually that common, much more advanced than the knowledge of the students regarding alternative proteins or regarding cultivated meat and other topics. So we actually put this question, is basically if education can influence our perceived of food and the impacts of food. We are going to cover this a bit. And with that, we founded almost 2 years ago, but I think 1 year and a half, the Alt Protein Project. And this project is basically an engine to actually generate more awareness and more education regarding alternative proteins. This is an international project. So, and we are the first ones in Portugal, and we are here in Lisbon. This project is somehow funded by the Good Food Institute, because we can actually apply to funding, and we are funded by them. And the Good Food Institute is an international non-profit. They basically work in alternative proteins, and this means plant-based proteins, fermentation, and cultivated meat. And they do works in science, policy, and industry, and nowadays they are throughout the world. We actually have close contact with GFI Europe. Here is just for you to see where is the alternative protein project. So we have this tiny dot, but we are very proud of this. So nowadays we have 70 chapters throughout the world. Most of them are still in the United States because GFI is original based there, and you have several projects like ours. And so our objectives are very clear. This is a bit descriptive. So basically is generate education and awareness, and in this case, Alt Protein course, lab visits, challenges, ways of thinking about these, workshops, and then social events. And we have been doing this mostly at IST because our team is mostly from IST at this point, but we are proud to actually already be in collaborate with the Faculty of Science and o Instituto Superior de Agronomia, ISA. And here, just to kick off a bit what we are going to do here and to think about alternative proteins. So I don't know if you know about this, but probably you do, because you are from environmental engineering. But we have here some challenge to face in our near future. It is how are we going to feed our population a bit more sustainable than the way that we have been doing. This is some numbers that we are not going through, but we have some hurdles regarding the conventional ways of producing fish and meat. And basically alternatives can be very good here, mostly due to environmental impacts that I will not address those numbers because we will about to have the experts talking about this, but also food safety, animal welfare, and accessibility to food. So the 3 alternative proteins that I have been mentioned, that are basically cultivated meat, fermentation-derived products, and plant-based meat, all of them in different ways can actually promote those advantages regarding conventional meat that I was mentioned. And in here, actually today we have a member from the board of Cell Agri Portugal that you will heard about very soon, talking about this. So the concept of cellular agriculture and how can you, by collecting cells and growing them and cultivating them, can create products that are a bit or more environmental good when we are choosing our options. And here regarding just specific plant proteins, you will heard soon Professor Anabela Raimundo. So her lab focusing much more things than this, but and actually a lot about products that go to the market, but mainly innovation. And you have here just one example of plant-based products that basically can, so in this case macroalgae, they can be used here as a solution. And this is the case of fermentation-derived products and microharvest. Actually, I'm very sad to say this, but Dr. Luisa cannot join us today due to unpredictable events. But microharvest is a very good example in Lisbon of a way of producing fermentation-derived products. And then you have cultivated meat that you'll heard all about this. It's a novel way as well to produce meat. And you have Dr. Felipe Soares also talking a bit about this in soon. So the great thing about having all these people here today and talking about the three main topics of alternative proteins is basically this graph that I really like to show, the way that all of the three can actually be very beneficial for the environment and for much more other reasons, but the way that they can actually collaborate between them. So without further ado, you are not here to listen to me, but to them. So I think from now on Gonçalo can follow and start this roundtable discussion. Gonçalo and the Professor Anabela, Dr. Felipe and Ricardo. So yeah, I'll be here.
Nossa convidada, então.
Shall we do it in English? Is that okay for everyone? Yeah? Perfect. So, welcome everyone. Thank you, Diana, for the wonderful introduction to what we're going to speak here today. So we heard a bit about who we are and what this roundtable will be about, but first I'm going to let each of the speakers introduce themselves, maybe a bit of your background, and also what you do and what's your role in professionally. And we can start.
I chose the wrong spot. Hello, hi, I'm Philippa. I'm actually a technical alumni, so I did biological engineering here in EST a few years ago. Then I moved to UK. I did my PhD there in stem cells and regenerative medicine. I work in the field of making cells for the cell line disease modeling, and then I went into cultivated meat in 2020, and I work as VP of R&D at Ivy Farm Technologies, which is a company in UK that is doing pork and cow from cells, from cultivated cells. You kind of saw from Diana what that is, but maybe we can go into detail a bit later. And after that, I actually, in August this year, I moved to Portugal after 18 years in the UK, and to join Cell for Food. And in Cell for Food, I'm the CTO, and I overlook with my colleague Carlos as well the R&D, so the scientific side of it, technology side. And what we do food based from cells. So we take fish, mollusks, and crustaceans. We started with octopus, and we take cells from these animals, we grow them in culture to the aim of getting food, protein, like you just saw in some of these pictures. Thank you.
Thank here. Annabella?
Hello everyone, I'm Annabella Raimundo. I'm professor at Instituto Superior de Agronomia, as you mentioned before. My background, so it's a very long background because I'm not so young. So I'm a chemical engineer, and then I studied food engineer always at University of Lisbon, and my PhD was in the same subject. I'm coordinator of the group Food and Feed from LIFT, that is our research unit, and we mainly work with the development of new food products, different types of products, but our main focus is related with rheology, food rheology. I mean physical properties of food and the relation with sensory evaluation. I started to work with the proteins. I was counting the years. I started to work with vegetable proteins, with the lupin protein. I started with lupin protein more than 30 years ago. At that time, for me, it was a concern to find alternative sources of protein. But now it's not one topic, it's a very important topic, it's a hot topic. We have to look for alternatives for our diet, and in our group we have different approach on this, with pulses of course, because they have a lot of benefits in terms of environmental and others, and from nutritional point of view are also interesting, but also with microalgae. In the last years we worked a lot with microalgae biomass. I don't know if you have an idea that we can have around or more than 70% of protein in a dry basis in such species like spirulina and so on. So when we think about, so we have to find alternative proteins, we can never forget the microalgae because they are really, really important on this field. So in our product development process, we use different techniques. Now it's very common to use 3D printing. Also, it's a common point with cell for food. But other techniques that are important and they are emerging in this sector. So that's it.
Amazing, thank you. Carlos?
Thank you. So, hello everyone, good afternoon. I'm Carlos. As I think we all are, I'm also a IST alumni. I did biological engineering and then a PhD on stem cell bioengineering. So at the time, the focus was more on the biomedical field, so developing ways to grow cells in the lab, to develop in the beginning more towards cellular therapies. Then the cellular therapies lost a bit the enthusiasm, and the shift was a bit towards models of disease and ways to study the cells in vitro towards development of new drugs or to understand toxicology. That was a period of time that lasted until last December. I was a researcher at IBB, the Institute of Bioengineering and Biosciences here at IST. At some point we moved to Tagus Park. The cell cultivation labs are located in Tagus Park. And then the person to blame on a change of topic is Diana, because she started also with Gonçalo. I won't tell the whole story. This is a story that has been told many times, but I will, in a nutshell. So they were in a course here at IST, entrepreneurship, I guess, where they had to present an idea to start a business, and their idea was to do cultivated sushi. So to cultivate fish cells to produce sushi in a more sustainable and healthy fashion. And from there on, so the idea of moving, as I told you, we were producing cells in big quantities. So the process was identical. So instead of human cells, we wanted to produce animal cells. And then from that idea, a whole research team emerged in our group that was interested in exploring the cultivated meat production. And more or less, at some point in that period, we had a meeting with someone called Vitor Verdelho, who then created Cell for Food, and who also had the idea of creating an association to develop this field in Portugal. I was also one of the co-founders of that. It's called Cell Agri Portugal. It's a Portuguese association for the development of cellular agriculture. And in that sense, we have also promoted a lot of initiatives with students, with other research groups, culminating in so far 2 big international conferences here in Portugal, and the 3rd one is on the way. So yeah, that's the last moment. Last December, as I told you, I switched from academia to the industry, and I joined Cell for Food with together with Filipa, that was already there for 2 months or something. So
Newbies.
and we are now located also in Tagus Park. So sorry, it was maybe a bit longer.
No, that's fine, thank you.
Yeah.
And it's good to kind of hear where you kind of came from and the path towards us being here at this roundtable as well in IST. So we heard about different technologies that are within the alternative protein realm, and I was wondering if it would be good. So Diana mentioned a few kind of benefits that these technologies might have versus conventional agriculture, but I think it would be good if we could get some more highlights from your perception on the advantages of whether cultivated meat, maybe seafood or even other types of meat, but also plant-based proteins, and maybe if you have any hints of what are the benefits of them versus other alternative proteins, or why we need a diversity of them. And I guess we can start with Annabella this time, so it goes around.
I think that you use the keyword diversity of protein sources. I think this is the most important thing we have to consider. When I look for this, for alternative proteins, first of all, we have to think about why we think about alternative proteins. And the question is not easy, because we are now facing a very huge increase in the population growth, and we have scarcity of water, we have scarcity of arable land, we have scarcity of biodiversity, and we have scarcity of protein. So first, we eat a lot of protein, more than it was necessary. This is true. All of you and me also, we eat high amounts of protein. The recommendation is about 60 grams per person during a day. And it's easy to calculate the amount of protein you eat. But the conventional agriculture systems are not able to follow this increase in the population growth and the protein shortage. No way. So, no way. And what we have to do? I think we never can look for these different sources of protein with thinking they are competing to come for our diet. All of them are really welcome, because if you have this problem, we don't have protein for the next years, we need all the protein that we can get for our food system, okay? So, plant-based products are really important. The vegetable proteins, namely the pea protein, shake pea, and so on, that you have a lot of products with this, are important. They have their role, but other proteins are also important. And we will continue to eat meat, we will continue to eat fish, but we need the products that will come from alternative systems like cellular agriculture. So, not competing between them, but coming together. And we have one thing that is related with diversity, that is the type of protein. When we have proteins, they are not, all of them are not similar. It's not a protein, no. proteins, as you know, are they have a lot of amino acids, and for instance, you know that this in our traditional food we eat beans and rice. Okay, it's common to have it also in Brazilian food and so on. And we think, oh, okay, it's good, it's fine. But if you look for the amino acid composition of the proteins, they can complement one with each other. If we look for pulses, for instance, they are rich in lysine and are poor in methionine. And if you look for the composition of cereals, is in the opposite side. So when we mix them together, we are making a certain combination that we can get all the amino acids that we need, essential amino acids. So what I lose my I lose my way, but looking for diversity of proteins is more or less like this. And this is the main message. The advantage is not to have one type of protein in our diet, but is to keep all of them together and complementary preparations and food approaches with different type of products in order to have all of them together for healthy products and to have a different diet. We have to rethink our diet. It's mandatory for the next year.
Thank you. Yeah, that was great. Actually, thank you. What about in your perspective in terms of cultivated foods, let's say?
So I agree this is all about alternative, diversifying ways of making protein. So it's not a competition, not with traditional, not with aquaculture in our case, not with plant-based, not with microprotein. It really there's a space for everyone. It's how we can make the best food product for everyone in the future, and all have their different places and where they fit better than others. So that's super important here. I think when we in cultivated meat can also help in this endeavor of making food is the fact that we build food in bioreactors, as you have beer in bioreactors and for big fermenters, as you have bread. So we make anywhere that has a fermenter. We don't need land. We need water to give the media to our cells. These media have these amino acids that the cells can grow on. But we don't need arable land. We don't need a sea. We don't need a big tank where fishes are swimming, not flying. I wish. One day I'll see that. So it's opportunistic in a way that it's different from what is out there. And also, of course, the fact that we ourselves, another advantage I would say, is the fact that we take cells from the fish. So like say a muscle of a fish or an arm of an octopus. We take cells. We take the little expands into a dish, we wait for the cells to grow, we give them these amino acids, other nutrients, the cell grows, we grow them in this controlled environment, no microplastics, no antibiotics, and we're able to control these steps, and we're able to build several liters of biomass and scale this eventually when in a few years, but we will do that. So that allows not to keep sacrificing animals, and that's also something that we in cultivated field feel very strong about it. The fact that you don't have to go back and rely and on animals to keep producing that. So that's definitely one of the things that I think all of us that are in cellular agriculture are quite passionate about. That is also the fact that we're also minimizing the number of animals that we're actually making protein from.
Yeah, that's great. Thank you. Yeah, and I was thinking even as Portuguese, because when I kind of like delved into the field, that ability to grow cells, from a certain animal in places where it might be depleted of that animal or there might not be an environment for it, kind of reminded me how we kind of like eat so much codfish and have this thing in Portugal where we don't actually have codfish in our seas, but it's something that we all love. And if we could have any opportunity even to improve our business in Portugal, our food industry, if we could produce our own, if not just to be able to eat it once per week. You don't need to change every time you eat, but I guess Annabella also mentioned that very well, is that food diversification and protein can come in every meal, and you don't need to like a bite to one or the other. It's about like trying as much as you can, and if finding foods that you actually think are tasty. What about you, Carlos?
Yeah, I was thinking you told that idea of producing the codfish in Portugal, and that becomes even more important in the geopolitical situation that we are facing these days, with commercial routes that are disrupted because of these conflicts, military conflicts, and so on. So it's also important for to allow the food security in each country to be guaranteed for everyone. So that's also something in which these alternative proteins can help, because we rely a lot on imports from other countries and so on. So yeah, that's also an advantage. But I think most has been already said. Just two quick ideas that obviously there are problems in the conventional agriculture production that have been mentioned, but we really need them to exist. So we are not planning to completely replace the conventional agriculture from one day to the other. It's just another alternative that can work together with the traditional agriculture to kind of build a new food system. And also between the different alternative proteins, it's possible to have interactions between cultivated meat and plant-based, so kind of hybrid products, where you have a kind of a plant-based matrix that can then have cultivated ingredients. The most obvious one is the cultivated fat, because fat is animal fat is kind of responsible for part of the tasting elements that we are used to in animal meat. So if we can combine that with plant-based materials, we can have a kind of new option for putting in the table of everyone. So I think there's a lot of ideas to explore out there. It's our job to also explore it.
Yeah.
I'd like to clarify just one thing and to rethink about the mix of proteins. When Filippo was explaining the cell culture, the cell cultivation and the products that we can obtain, I don't know if you are really, if you have an idea about this process, an exact idea, but the question is, when they have, for instance, octopus, in the end, they will not obtain an octopus. I don't know if you have, because a lot of people think about that you are cultivating the octopus, and in the end you go to the fermenter and you take your octopus. It's not true, okay? So, I'm looking for Diana. Diana has a very beautiful fillet, salmon fillet, very interesting salmon fillet, obtained by 3D printing techniques, and it's very interesting. But the question is, when we have this technique, the cell cultivation, in the end you don't have a food. You don't have a food. You have an amount of cells, you have like a paste reaching the cells from the original animal, okay, but it's not a food. It's not an hamburger, it's not an octopus, and so on. So in this sense, we have to use this as an ingredient for preparation food, and we have two ways. We can use it to mimetic the salmon fillet, or you can prepare other products like sausages, like hamburgers, like what you want, using these proteins. But the most important thing is not the way you prepare the food, is the increase in protein alternatives. So you have another alternative to prepare foods. And when you prepare these sausage fillets and so on, you have to mix this paste with other ingredients, not only proteins, but others, in order to get good texture. And in the end, this type of product must be tasty. So I think this is just to clarify, because I'm not sure if you are very clear with this idea to obtain an octopus at the end of the fillet.
Yeah, maybe we can give a bit more highlights about it if you guys feel comfortable with that. And then we have a Q&A afterwards, so we can also talk about it. But just really briefly, what Annabella is saying is really true. I mean, there's different ways and different types of products that we can achieve with cellular agriculture, and nowadays it is mostly what you were saying, where you get the cells and you use them as an ingredient for something under a plant-based matrix, or with other alternative proteins. So there are these second generation products that we don't know yet how scalable they will be, and those really try to mimic a piece of tissue, and they use scaffolding techniques and usually various cells. But the technology, I mean, it depends on our opinion and what we know, but I don't think it's there yet in the world. Maybe it will take a bit longer, and obviously that can be used in tissue engineering. That will be literally a tissue. It will never be an octopus, a live octopus or something, you know? But muscle cells do contract, so we get to a point where you actually see or can see, you know, real tissue. I don't know what.
Yeah, no, I think both are, yeah, totally right. And Gonzalo and I have worked together in London in the same company. So yeah, no, you're totally right. You know it from inside anyway. But yeah, right. From the bioreactors, actually, what the companies produce is a paste. So pork paste, cow paste, fish paste, octopus paste, still a paste. So we are in the process of then making hybrid products, as Carlos was mentioning, and make it something that is appealing to the eyes, because you don't want to eat a paste. No one wants to eat well, maybe in the future, but no one wants to eat a peel of proteins as yet, as dinner or lunch. So what we want to do is to make that paste something that is appealing and it resembles the food that you used to see. And that's when enters hybrid and mixed with plant-based. A lot of the hybrid cultivated meat products that you have already regulated, they have mixed protein or plant-based, so pea protein, soy protein, any others. So that's what we are now. When Gonzalo was saying is where we want to be in some point that we want also to get to this more complex, and it looks really nice and growing in these scaffolds. We're not there. I totally agree with you. That will take loads of time. So I'm not thinking of those products yet because they will take time. What I want to do is enable version 1.0, and then others have to me, which already working on that, we will be enabling in the future version 89.0, I'm sure. But will take time, because even this one, which is the simple version, will take years to scale, to get the cost down, to make it to go to the supermarkets and get it next to the offers that we have there. But we're just the beginning. The field hasn't started that long ago, and we still have a lot to do. But we're here to do that.
And I think that's a good segue for, my next question, or kind of like point of discussion, which would be, we talked about advantages of these technologies, but it would be good to hear a bit, on the bottlenecks that you're facing or that you feel like the industry is facing in both sides, and that can be from a consumer perspective, but also an environmental perspective, maybe, since we're with a lot of environmental engineers. You can go first.
Yes, okay. So I will mainly focus on vegetable proteins and also in microalgae, because I'm not expert in the others. So I would like to talk about this. I think in terms of when we look for this, traditionally we just see advantages. It's difficult to find negative points when you use pulses or when you use algae. But if we think a little bit, it's important to note some points. One is related, so starting with pulses. You can find in the market different protein isolates. Lupin protein isolates, pea isolates are very common, and so on. But one thing that is really important when we talk about proteins is this point. To get proteins, to extract proteins from a pulse, from chickpea, from lupin, for what we decided to extract, we have other fraction that is not protein. And normally we have our focus on the protein fraction because it's the most interesting in terms of nutritional point of view and so on, and we forget the other one. And this doesn't make sense from the environmental point of view. So I think that this can be an advantage when we use the protein extracts that are very common, and we don't use the flour obtained from the pulses. Okay, so, and you can say, but why you don't use just the flour if it has sometimes, in pulse, it depends on, for instance, in lupin you have more than, you have around 50% of protein, it's too much, but we have the other 50%, okay? So, from the technological point of view, when we want to prepare an emulsion, foams, gels, the foods that we eat, the protein isolates or the protein concentrates are much better because they have higher functional properties, from the technological point of view. And also when we taste it, you don't have aftertaste, you don't have a bitter taste, and so on. So the market of the protein isolates and protein concentrates is growing a lot, and it's really a trend for the plant-based products. But I'm always talking to the companies, please look for the other 50%, at least, sometimes can be more depending on the pulse, because we have to look for this with the concept of biorefinery, so we have to add value to all the fractions. And sometimes it doesn't happen, and we have a byproduct and not a co-product, and we don't introduce it again in our value chain. I think this is really, really important. The same for the microalgae, the same concept for the microalgae. Microalgae is a huge source of protein. We can also, as I mentioned before, you can have 60%, 70% of protein in a dry base. It's really, really nice. If you eat a spoon of spirulina, you will have your protein power for per day. But now we have a trend to use protein extracts from microalgae. I don't like this idea so much with microalgae because they are really interesting when we use the wool biomass, but anyway, if you extract the proteins, please pay attention to the other part. I think from the environmental point of view, this is really, really important. Nowadays it's mandatory because we have to look for this as a circular economy, and if we have this context that I described before, it's impossible to have waste or have byproducts that we cannot add value and use it again in our value chain. So I think these are one advantages in our stars that are the pulses and the microalgae. I think it's a real problem that we are facing. Okay?
And do you have any, I was thinking, do you have any, because I didn't know that on the pulses side, do you have any example of or a suggestion of something that we could use the side streams for, or any?
Yes, a lot of them, because we are talking about polysaccharides, sometimes you have fat and all of this are, from the nutritional point of view, they are very rich. For instance, we can prepare bread with not only without wheat or without other flour, but we can mix this side stream with flours, with traditional flours, to have breads with different compositions, but with tasty. We have examples of this, but they are tasty. And from the nutrition point of view, you can always win when we have mix of different ingredients, because you increase the diversity of your diet. So yes, it's easy to do that. Okay, but it's important to have one thing into account, that is the way you extract the proteins, because you have to use green extraction processes in order to can obtain all the fractions, because you use solvents, different types of solvents, you can have problems to add value to the other fraction. Okay, this is very, very interesting point. Thank you.
Interesting, thank you. Well, what about cultivated meat?
Bottlenecks?
No
Yes.
advantages.
more advantages.
No bottlenecks.
Bottleneck, well, we could be talking all day long about the bottlenecks of cultivated meat, but just to name a few, I would say one of the major ones is still basic science. So we know a lot about culturing human cells. We know a lot about culturing mouse cells, because they are used as a animal model very often. Maybe we even know more about growing mouse cells than human cells, but we don't know so much about bovine cells, porcine cells, avian, like chicken and others, and especially we know very few about marine species like fish and octopus and other. So it's not so straightforward to isolate a cell from an octopus and then to know exactly what are the nutritional requirements of those cells to grow in vitro or in a bioreactor. So, and of course then to characterize the cells in terms of gene expression and to direct them towards muscle, fat, or whatever you want to produce for your food products. So that's a scientific bottleneck. There's also regulatory bottleneck because these are novel foods that are not consumed yet in, let's say, in Europe. That's where we are. So the European Union has a very solid regulatory approval process for these novel foods. So it has to go through a lot of, you have to demonstrate a lot of things in order for your product to be put in the market. And so far, in terms of cultivated, we have 2 requests in Europe, I guess.
That we know of.
That we know of, that have been advertised at least, so it's not that much, and it's a request for approval. They are not approved yet, so 0 approved products. We have some in the US, we have some in other locations like Singapore and others, but in Europe, still we don't have any cultivated food product approved for marketing. So that's another bottleneck. And finally, but not less importantly, we have the economical bottleneck, which is the problem of producing a product that is price competitive with other products already in the market. So it's kind of expensive to grow animal cells, still because we are picking up a lot of technologies from biopharma, which has a completely different level of characteristics in terms of the safety and the quality of the products that you need to use. So you need to reduce greatly the costs of producing these cells before it's competitive with also there's a lot of support from the countries towards the conventional agriculture that allow them to reduce a bit the prices. So yeah, there's a lot to be done before we can have these products in the supermarket near us.
Yeah, thank you. You mentioned really good points, and you can see that, you know, in plant-based the challenges are already, we would say, focused and more on the scale and trying to make this, you know, a reality. Whereas in cell ag, we still have many issues facing everything.
I think that's it. I think Carlos spoke about the dark and then the bloom of cultivated cell ag. But it's really a nascent technology. It's very recent. Octopus cells, we only found papers of octopus cells outside and kept in vitro for 4 days. That's just the challenge of where we're facing. And the same for other fishes and the same for other animals. So we really basic science here that is using technologies of pharma, as mentioned, quite expensive, but also an opportunity there. This is a side thing, but if we can in cell culture actually decrease the cost of media bioreactors that is used in pharma has a lot to learn from us. So it can actually good things, not just food coming from cell agriculture actually, but putting that aside. So I think is yes, is a nascent technology, as others have been, like electric cars, cell phones. All these things kind of take time to get out of it, and we're in the very beginning. But saying that, it's a lot that we can do, and a lot of progress we actually have done in the last few years. I think what happened with our industry, unfortunately, there was a lot of promises in the beginning that would solve a lot of things, that, you know, the issue, food for everyone in one go and very quickly, and that annoyed a lot of private investors who put a lot of money on our field. So that hasn't really helped. So we have a long journey away of us, but we're also very young and new, and there's a lot to do, but I think there's a lot of opportunity there too.
That's why we need all these guys to
Yes.
get involved.
I'm curious about one point, about energetic costs of this fermentation process comparing with the traditional agriculture. This is also a bottleneck, or no?
If you look into meat and cow and chicken and pork, you see there's a lot of LCAs, so life cycle analysis,
Yes.
which probably a lot of you have been heard of and will be probably doing in the future. That those life cycle analysis have been really showing that these animals that really take a lot of land and water and emit methane to the surface. They're really a case of decreasing the bioreactors itself. If you use renewable energy, that will decrease the amount of all these resources. For fish, is a bit less. There's not many LCAs on that. We've been looking forward to do that. Octopus even less. But it could be less. Although we still have fish, you still have aquaculture, which is the other option, which is also not very friendly. So although it's less data on the fish side, I believe overall we can make it cheaper, but that will also mean that we need to increase titers, we need to increase growth. I don't think the future of our industry is massive large-scale bioreactors, 250,000 litre reactors, 3 buildings bioreactors. I don't think we're going there. We'll have to do scale out, we have to do perfusion, there's other ways to do things. But yeah, that's still.
Okay, we cannot be focused on energy consumption, but also in the whole LCA.
Yeah, exactly. Yes.
Thank you so much. This is wonderful inputs. I'm not sure how we are on about time, but maybe we should move on to a Q&A, and if we have time, then we could speak about more opportunities, maybe for you guys to join the field if you want. Do you have any questions?
You talked about the cell paste and make it attractive to the consumer eye, but what about the taste and the smell? Do you think that the objective is it to make it similar to the original, or to make it a completely different thing and completely different product?
I think from our side, as important as is texture, flavor, and smell, yes, because that comes along with flavor in some ways. So that's as important as the visual part of it. So one of the bottlenecks, actually, not just cultivated cell agriculture, I would say maybe, to plant-based, is that the consumers are not aware or not used to this kind of technologies. A lot of people, I think they just or either don't want to try, or they just not used to it and prefer to look at the other side and go to the meat because it's easy to cook. My mum told me to cook meat from young, and I don't know how to cook other things. I could go to the vegetable aisle and I don't know how to cook. I think that's a lot of that, and if we can change that, and I think with younger generations, I think that will change, but it will take time. And I think one day that will help our products to get into the market. But I think nowadays, personally, others might have different opinion, but we are trying to mimic what people see, because that's what's appealing. That's what the sushi, the fillet, that's what people are used to it, and that's what people recognize. Oh, this is food. And when you come out of alternatives, it takes longer to get that consumer adoption. That takes time. So I hope we can invent and create new technologies. We were actually talking about some. But when we talk to people about them, they're like, I don't know that, I'm not so sure. So you have already another hurdle to overcome. First is, okay, I'm not so sure, but looks like what I used to, food. And the other one is that, oh, I'm not so sure, it looks something different. So it's also to get the customers on our journey, all of you, the clients, all of us, to eat something and try it. I think that will help the innovation of different products.
Do you have any comment
Yeah,
you'd like to have?
that's a very good question. Actually, the idea of doing something different from what we already know, and I think that's also an opportunity for this field, because of course we want to do something that people like and people kind of identify themselves with that kind of food, but we can also explore new avenues and maybe add things that doesn't exist in nature but can be interesting, and maybe there's people that are more willing to try different stuff, people that prefer their already well-known foods, but there is space for all. So I think that's a very good also opportunity for these novel foods, also to explore things that do not exist yet, and that we can create very interesting new products.
Sebastian, it's a very interesting question that, of course, I think we have to think about different ways to use this paste that you obtain. I usually say that to my students, and when we work in development processes, I always say that we need a lot from a food. Food is one thing that is really important for our life. So we like to have sustainable food. We are talking about that, and I think it was proved that it's a sustainable source of food. But it's not enough for us to be sustainable. The consumers will not buy a product because it is sustainable. A lot of studies about that. And it's difficult to predict what the consumers will choose in the now and the near future. There are a lot of models, there are a lot of processes to forecast what we are going to have. What is the consumer? Consumer is not a real person that has different approaches and different choices, but we need to be, we look for sustainable products, healthy products. We are always honest with our health, and affordable products. It's another problem. And in the end, they must be tasty. If they are not tasty, the others has no value, isn't it? So we have to have tasty products. This is the most important thing. We do a lot of science. We choose a lot of different proteins, different shapes, different ways to go to the consumers. But if the foods we launch in the market are not tasty, no way. You will not buy, and the success will not exist. So I could say that to have tasty products, in my opinion, and Filipe, I'm sorry if you don't agree with me, both ways are important. To mimetic the nature, of course, and I understand your point. People like to identify like food, but also to look, because I'm always concerned with the problem of alternative protein. We need protein. I'm not, for me it's the same if it is in a shape of fillet or if I use the protein to obtain a tasty product that it doesn't seem like a fillet or like an octopus. It's another way, and I believe so much in this way because it's cheaper. It's easy to control the ingredients and the formulations to get a balanced formulation with healthy products, and we will see the future. Both ways are important, and we can go in parallel. They can be developed in parallel, but I believe that it will be more interesting to have this space in the preparation of different types of foods, with different companies that are interesting and are looking for alternative proteins. It's my point of view.
Thank you. That's perfect. I was just thinking of a little add-on to the paste scenario. Did any of you ever smelled or tried cultivated meat here in the panel, or any of you?
Yeah.
So
you knew the answer to that.
I don't know. I'm just saying. Can we say it or not?
Yeah, we can say it.
I think it's just important to perceive what comes out and when you cook it, how identical it is to the real thing. So
Yeah.
I don't know, Philip, but if
Yeah,
you
no, I can tell my experience of trying different, not meats. Let's put it that way. I'm trying to be vague, but not too vague. Yeah, I think I agree that taste is paramount. If it's not tasty, no one will take it, whatever form it is. So that's the first thing, and we agree on that. So regardless of whatever form we'll have, if you don't have the texture of something, but at least taste. That's the most important. I don't know when we'll eat something that doesn't taste good. In terms of we have done scaffolds and stuff with meat and hybrid products. We had a long experience of making that, and I've tried a few of our prototypes and structured products mostly, which is fairly easy to do because you don't need any special technology to do that. You just mix with other food ingredients, and we make a burger, you make a sausage, you make other Asian food which is a bit more complex visually, but at the end of the day is minced. So it's minced meat, is non-texture, and that's fairly easy to do. But when you I don't know, when you put some of the meat we do in oil, it actually tastes like meat. It's just it's just quite rewarding when you just have something that you've just been growing for weeks, and everyone in the lab just cooking around the pan, and you just cook that for the first time. That was our first times, and then we had a chef, and then everything became much more posh. But in the beginning, when you just have a little pan in the lab and just fry it, or when our team just made octopus arms the other day, because octopus don't have tentacles, by the way, please, don't say octopus have tentacles. Octopus have arms. So the first time the team was just cook octopus arms with ourselves, that was just, it's just such a nice moment. And then, we'll have to expand that, but just that is just really nice, and it does smell and it cooks, and you just see all that fat coming through, and I think that's why we do it. But it's nice, it's really good. But then you just like, we go to the next question, like, okay, how much cultivated product you have in there? How does that affect taste? Is a world of questions that we don't have yet the answer for.
You're right. Totally right. Thank you. This is just to kind of like highlight that, you know, the potential also of these products, and that these companies are also making sure that, you know, they have products to sell for us that are the consumers, right? So they are doing blind tests sometimes with real meat, with plant-based meat, or with other alternative proteins, to make sure that it has a benefit for us, not just nutritional, but also, you know, tasting and, you know, tasteful products that we can buy in the supermarket.
And I think just so for us, we are a B2B company, so that means that we have a technology platform to make biomass. We don't call it cell-based, we call it biomass, a bit more fancy. But so this biomass, and we sell the technology for other companies to do biomass as an ingredient. So we ourselves, we don't do octopus arm. That's not what we are going to sell in supermarkets. We are providing the technology, octopus arm, other fishes in the future, to companies, to people that want to buy our product as an ingredient, and from them will be, who knows what people are going to build on.
Yes. Thank you. Any more questions from you guys? Yes.
And you mentioned the role of private investors in progressing and creating cultivated meat. What is the response of political stakeholders, and how is the EU responding to it? Is that important as well in how it's progressing?
Wants to go?
I can
Agriculture?
give some ideas. Of course, the political agents will have an important role, and actually the European Union has some programs to develop alternative proteins, like the Farm to Fork program and the Green Deal. So two large programs to develop the food system towards this alternative protein landscape. And actually, specifically about cultivated meat, there is a European project called FEASTS, which is coordinated by IST actually, with around 35 partners around Europe, and one in Japan actually. And the idea is actually to understand the advantages, the pros and cons of developing the EU in this cultivated meat space, and to provide guidance for the different stakeholders on how to advance in this field. And this includes traditional farmers, includes scientists in academia, the companies like Self4 Food and others that are starting to work in this field, and how can they interact together to have products that are safe, that are nutritious, and that are affordable for the European customers. So I would say that at this point the European Union doesn't have a solid position against or in favor of cultivated. They are kind of studying the subject and gathering, and the role of FEAST is also to gather this information and to share openly with the different members of the Union. In the US, it's kind of currently a different situation. No one exactly knows what is going to happen with this new Trump administration. So we'll see. But overall, I would say that the political agents will say, especially because you mentioned the investment, the private investment is kind of not in the strongest moment towards the cultivated field, but the public investment is quite in the opposite direction. So I think the countries are investing in the field. They want to know more about what can be done. But yeah, as Filipe mentioned, this is an emerging field, so we are starting. We need more time to see what's going to happen. And all products have this up and downs in popularity and in investment, so we'll have to wait to see what's going to happen.
It's also to say that we are quite anxious about what's going to happen with the two companies that have submitted the dossier. So the one is Gourmet, which will make fat pâté, and the other one is Moser, which makes fat from pork or cow. I think it's pork. Is one of them. So we're quite curious about that because that will set up the whatever comes after it. There is two countries that already banned cultivated meat. There's specifically Italy. They have banned the selling and the making in their own country. The others have not done anything like extreme about that. There's Hungary, maybe. But it's expectation, and as Carl was saying, that's the private, because the private is there, but what the private wants to see, it's okay, do it but with less money. So it's still here, but we're not going to give you like 50, 100 million as some of these first companies had it. We're going to give you less money. So that's why we have to do the same business, with same job with less money. We have to do it better, which is not a bad thing because you're kind of selecting what's happening in the people and it's a way of select who is doing what they should be doing and not. So with that say that I think the momentum is still very positive because people believe, and specifically countries that's very positive is Asia. So Singapore, Japan, South Korea, they're also very eager and supporting cultivated meat as a technology. So, and also Dubai and other countries. So there is countries that are still very much pushing it. I think European Union are a bit more cautious on the way they, in general, approach things, and I think this one is definitely one of them too.
Just as a little add-on, the Netherlands is one quite different.
A good one,
Yeah,
yes.
because they have invested quite a lot and now 60 million just for cellular agriculture through public funding. So that's, and just another add-on, just because Carlos mentioned feasts and you mentioned the Italy ban, that's something that is still trying to be solved because they did effectively propose a ban within Italy, but those bans need to go to the European Union because of the free market laws, and the same was with Hungary. So I don't think they put forward the amendment on time, so it needs to follow a few rules and it needs to be on public accessible for a year or so, and they didn't do that, right? So we heard the talk about it a few days, so hopefully that's just populistic endeavor, let's say. But yeah, hopefully it will go for the better in the next years. Does anyone have any question, comments?
So you've talked a lot about taste of the cultivated meat, and my question is, well, we know from experiments and things like that the meat becomes tastier if the animal, like with the exercise that the animal practiced during its lifetime. So, like extensive cultures of cows, for example, will produce better beef, and salmon also becomes better when it comes back to the river, and it's a very harsh way to come through. So my question is, can we simulate that on cultivated meat? So can we make the cultivated meat practice exercise so it becomes tastier?
That's a great question, but I'm gonna leave the cultivating experts first.
Well, that's something that in my previous job, current job of Diana and Gonçalo, was a talk for a long time. The idea in this case to make a fish swim artificially, and of course it's not possible to make a cell to swim against the current, but you can use other type of current, which is electrical current, to stimulate the cells in a way to increase the kind of cell maturation level that you can have from a very naive muscle cell into a more differentiated and a more kind of akin to what you can find in an adult organism. So that's a way. There's a lot of tricks that the cell culture guys have developed over the years to maturate the cells from undifferentiated into very well specialized cells. And yes, electrical stimulation is one of them. As you know, the muscles have a lot of electrical activity, so that's one of the ideas to do that. But maybe I guess I have to elaborate.
Any addition?
No, I think that's Carlos just covered it. I think that's it's indeed like more like phase 36 of the version of the cultivated meat. So, but that will come eventually. But as you differentiate the cells, so at one point in cell agriculture we had the first bioreactor that would allow you to grow cells in numbers, and you'd have the second bioreactor wave, which would be different, and that would be, for example, electrical stimulation would align the cells, particularly muscle cells, because they actually align very nicely along each other, and they kind of form really like a muscle, like a smooth muscle that you'd see under the microscope, so just all little cells close to each other. So there is ways to manipulate that. And that the way perhaps to go for that is to kind of use scaffolds and kind of more complex type of bioreactors to allow that. And that would give you those structures like more like steak looking like from the beginning, and not just kind of more like meat structure from the paste.
Great job. I was just thinking out loud, like, well, I will now say it out loud, but like Kobe, for instance, and Wagyu, those are typical pieces of meat actually come from cows that have more relaxed lives.
Massage,
so
right?
They get massages, and usually if you look at those pieces of meat, it's usually marbled, like a lot of fat. So this to say that fat is also extremely important to taste, and maybe us as an industry should maybe focus on something that is easier to do than, you know, stimulate maybe the heartbeat. But it's definitely a good shot, because this is one thing. One thing is to do, you know, Wagyu cells for a burger, but another is to make a proper steak. Then we need the muscle to be very similar to the live one, so it's a very good shot. Yes?
I don't know if it's a naive question or not, but I want to know how the cells are extracted from the animals. So it's from the beef or the fillets to create the paste, or it's from the animal, so we have to kill the animal to extract the cells, or not?
So for example, for octopus arm, so octopus have 8 arms and they regenerate arms, which is great. So what you do is go there and you cut the tip of the octopus arm, and that's what you take into the lab. And what you do in the lab, then you just section that, put in culture and grow, in simple terms. For example, for an animal, you have biopsies of the animal. So many lines or many attempted lines have been done with either animals that have been killed for meat consumption, and someone goes there and just takes a little bit of the muscle, for example, of the animal. Others have just gone to the field and just make a puncture. So we have like little pens with a few millimeters holes, and you just puncture the animal, which it really is a big animal, so it doesn't really bring that much pain to it. And you do it with veterinaries, and you do that live animals. So it is also possible to do that depending on the animal size and everything. But depends on what you're doing. For example, if you do fish, we just have to sacrifice the fish, because there's yet no way to kind of put a fish biopsy on the fish and then take it into the sea. Maybe you could have with bigger animals, but not smaller. So it does depend a lot on what it is. But the beauty about it is that when you take those cells and you keep them in culture, you don't go back to the fish. And in what you want to do is just culture those cells so many times in culture, and expand, that from a few million cells from the beginning, then you have kilograms of cells in the end. So you don't have to go back to the animal, and that's the beauty, but also the part of the hard work of it.
Any more questions, guys?
Just one more thing. Can we simulate any part of the animal?
Simulate.
Cultivate, sorry.
In theory, yes, of course. I mean, if you take the right cells to like we have seen the foie gras idea, that's from the liver of duck. So that's very specific cell culture. Other people are doing muscle mostly because that's what we eat. I mean, we're not doing bone, something we just get rid of. But yeah, in theory, you could try more exotic cell sources as long as you know how to cultivate them, especially if you use embryonic-like stem cells that can be differentiated into any tissue. It's a very good opportunity, but comes with the challenge of knowing how to direct the cells in, say, kidney fate or whatever. So, but the short answer is yes, it's possible.
Does anyone want to comment?
What are some of the biggest challenges to scaling this?
Cultivated, yes.
Yeah, one of the biggest challenges to that is in terms of we're talking about if he's talking about scale, is I would say is the cost of the media. That would be the major and the first challenge because the techniques that we've been used, Carlos and I, we were trained in regenerative medicine, so we're using very expensive media from companies that make a lot of money by selling us, the researchers, and others those exact medias and growth factors and all that. So there's no really cheap option yet of these media that we can use. That's what we're trying to do by using other alternative ways and to give those amino acids and those proteins to the cells. So that is because no one invented this before. So we have to find a solution to our problem, which is cultivating cells, but very cheaply, because when pharma can just, you pay a lot for a pharmaceutical or a drug, for meat you don't. So the major challenge is indeed the cost of the nutrients and everything that enters the process. Then you have the bioreactor, which there's a cost to it, all the metal. You have to grow reactors in these metals, you have to prepare a factory. But once the factory is done, that's just a capex, that's not the biggest cost. Then OPEX, everything that is consumable, it starts to be an issue. So yeah, factories take a lot of money to start with, and then you need to pay for that. But at the moment, our major problem is indeed the media and make the process cheap, because meat is cheap. Although it's not as cheap as we think of, because the meat, the eggs, everything we pretty much meat-related we buy, they're so heavily subsidized that if we were buy at the cost that the farmers are actually spending, we would be paying so much more. But unfortunately, or fortunately, for us it's good. But for our industry means that we actually have to reach very low numbers because we're not subsidized, and they are traditional meat.
That would be interesting also to hear the challenge of scaling these more plant-based products. What kind of challenges are out there for the microalgae or other kind of vegetable or non-animal origin?
I think that in this stage the challenges in terms of processing are not so much, because from the pulses, for instance, there are a lot of processes to extract the proteins, as I mentioned, but one challenge is to have green processes, in order to add value to both fractions, as I mentioned before. In terms of microalgae, of course, it's a younger product, and the protein extraction is not difficult. Now we have different methods to promote the cell wall disruption. That is a very important step when you have a microalgae, that is a microorganism cell, so it's a cell, and you have to break it in order to obtain the compounds, and then you can have different types of methods to obtain the proteins. Of course, we need to have we need the proteins with a high functional activity in order to get good emulsions, good food systems. In this way, it's important, and the big challenge is to preserve the protein structure, namely don't have the denaturation process that can turn the proteins not so interesting from the functional point of view. But I can say that at this stage, the most important challenge is related with biorefinery concept in order to have all the fractions at the same time and get value for all of them.
What is the knowledge sharing process like between companies now? Is it open? Is it closed? Can you say something about that? Or not really?
I don't think that will just relate to cultivated meat or cell agriculture. I think it in general companies they don't tend to share a lot of their IP because that's exactly what makes their product. So I don't think there's any difference to other industries. Mostly when you're starting something, and cultivated meat is the same. So if we have something that will give us the edge, we'll keep it to ourselves. Although there's also a way to protect the knowledge is through patents. So many companies, including ours, we put patents as well to protect our knowledge. And as you put a patent there, of course, there's information that others can look on and see what's development that the companies are doing, although you cannot use them, but at least you have access to it. So at the moment, I don't think it's any difference from others. Of course, research, if you do a lab, if you don't do it in a setting of a research, then it's much more open, for sure, because you publish, and it's up to actually your aim is to publish, you have an obligation to publish, that's why you get a grant, because you get a grant to make it public once companies know, and that's why it's much more difficult for us, to some ways, to get money as well from public funding. So a bit of a balance there.
Go ahead.
Just my double role as part of a company, but also part of a non-profit organization. I have to comment that this is part of the problem why the cultivated meat is taking more time to reach the market than probably would be necessary in theory, because practice is very different from theory. But we saw in the beginning of the field a lot of companies are developing their own product from cell lines, culture media, bioreactors, all in-house. So in parallel, lots of companies doing the same kind of studies in different locations, and the time could be really have been shortened if some level of pre-competitive research would be shared between the different companies. Of course, this is a very idealistic scenario, and it's not what mostly happens. And besides patents, sometimes companies rely on trade secrets, so they keep it close, even within the collaborators. So many people only know how to do a part of the product and not the whole product, a bit like Coca-Cola. So no one knows the recipe. That's why it's so characteristic, and yeah, it's not an ideal situation, but probably is the one that allows the field to grow larger. So we'll have to face. Although, of course, as a non-profit like CELAC Portugal, we want to facilitate the communication as much as possible of the findings between the different agents. But of course, people have to protect their business.
Yes, and it's the same way with other technologies. When you are starting, you have to have a certain degree of protection. Then when you are in the market, you can open step by step, and in the end, when we are here, we will not be here in the next 50 years or things like that. Probably this technology is something that everyone knows how you can do that. A lot of companies doing this, but in the beginning it's normal. It's the same way with other technologies, with other products. So
With farm.
yes, it's the same.
Is it resource intensive? It is,
Yeah.
but it is the way it operates. And that's why some of these fields really require that early public investment, just to really fill those, pre-competitive knowledge gaps, so that every company can actually use that. Because even if they want to share things that didn't work out, that's also a competitive advantage. So you really want to keep, your trade secrets. And there are non-profits, like Carlos mentioned, not only CellAgri, but others in the field that are trying to figure out better ways to move, not extract, but use information from companies. But so far, I think it's.
I would say, having worked most of my life in companies, in very similar, many different companies, we do collaborate a lot with each other as well. We just don't like to say the secrets, let's put it that way, but we just collaborate. We need each other to make products, we need each other to grow, we need each other's technologies. So there's a lot of collaboration still in the field, maybe not as much as non-profit and academia would like to, but that is impossible, otherwise we wouldn't be a company. But there is a lot of collaboration still. That's why we're here, that's why we do CellAgs, that's why we go to conferences, that's why we do posters. We still do that, but there is a level of refinement into the detail, one can say.
Any more questions, guys? You good? Are you interested in the field? Do you want to know what an environmental engineer needs? Or what can you help in the field? Well, just connect with us, please. Think about if you're interested in the field. I think we're all open to.
Yes, at least as consumers, they will be interested because they will have no way.
I hope so.
Because in 50 years, they have to catch all the protein sources. So I could say that as consumers, you have no way.
Trapped.
But I think that's part of our job here. We do, this is also about education. It's about educating the younger generations, what's to come. Because there won't be as many choices as we have today. And I think that's part of the job that we're doing here. It's not, just defending our courts. It's really to try to say there's a lot of options here, but you guys are going to taste a lot of them and be part of your normal food and dairy input.
And it's important to not be, I forgot the name, neophobic. Sometimes the consumers and young generations are neophobic. They are afraid to taste different solutions, different shapes, different smells. When I say so, I have here a very interesting product with algae. Sebastian knows exactly because we work in the project together. I will not taste. I don't like it. Okay, give time. And you have to eat. So it's important to don't become neophobic.
I actually have a question for them. Between you, who would be interested in trying one of these cell-cultivated products if they were available? And be honest.
Wow.
Yeah.
A good market.
And if it was a fermentation-based product, would convince any of the skeptics, or not so much? Is it? Okay.
Yeah, we didn't speak.
I'll try all.
And algae-based products?
Same hands up.
Actually, nori algae, that's probably one of the little things that, like, fried nori is really nice.
We have several solutions for algae-based products.
So why do you think it will take time for them to get to the market? Why do you think, they ask us a lot about cultivating meat, about this question. Why? But for you guys, because algae is more advanced, why don't we see as many algae products in the market?
No, it's a long story. Now, so we are always looking for the trends, for the food trends in the market. As we work with companies, we are always preparing foods to go to the market with companies. And last year was the first year where we had one trend related with the ocean of possibilities, was the name of this trend. So I believe that now the consumers are prepared for this, but the question is mainly related with flavor and mainly with the color. I think it's not a very important issue because green products are most common today, but it's mostly related with color, not with color, with flavor, but the smell, the strong smell, what we call fishy flavor smell. And we are working in different ways. We have different strategies in order to mitigate this type of smells. Sebastian developed here in IST, in a project we have together, strategy using enzymes in order to convert the unpleasant smells in very pleasant smells, for instance, and we applied this algae, for instance, in bread and cheese, different types of cheese, in order to see, it was not easy, but we have other alternatives, different ways to go there. One thing that is really important is the food pairing. You have to know exactly what are the ingredients that will match in a perfect way with different types of algae, because all of them have different smells, of course. And I think the bottleneck to go to the market is mostly related with this, the smell. People are not prepared to this type of smells, and I can say that you can find very bad experience in the market. So one thing that I'm always work with the companies is we have to promote really good experience to our consumers, because for instance with your products, if you go to the market with a cellular based product and the consumers will have a bad experience, you are mimicking a beef, and when you taste it, it's not a real scenario, okay? And you will eat the beef and you say, oh, it's terrible, the taste, blah, 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 blah. You will not taste again. You will not buy this beef again, because the food consumers have this problem. You eat one time, and if you don't like, you will not repeat. So it's really, really, really important to go to the market with good experience for the consumers. And I think this is also a problem. I believe that now the consumers are prepared. Not I just believe, but there are a lot of studies about that. The market is not prepared to have much more products, and the launch of these products in the market, microalgae-based products, increased around 40% in the last year. Of course, it's not a huge value, because if you have two products and you have an increase of 40%, or at least you will have 4 or 3.5 products in the market. But it's a way. Now I believe. But I think we had this problem in the beginning, bad experience, you know.
Yeah, no, I agree. And I think some plant-based products are also like that.
Yes.
So yeah, no, bad experience are
Avoid
turning people
yeah,
turning
yeah.
people off, and then it's like
Because they will not want to taste again.
But the algae thing you mentioned about the smell is really interesting. I haven't thought about that. Yeah.
You happy, guys? Enjoy it? Yeah? Not asleep? No? So, I mean, thank you so much for this. Thank you as well for organizing. Hope you all enjoyed and learned something new. And again, I think we're all open, at least LinkedIn or something, for any comments from you. Thank you.
Thank you.